N6946 BH1 sat in the fireworks galaxy, looking like a star that should end in violence. Not a bright supernova, not a spectacular cosmic finale, but a dim red giant that swelled, shed material, and then seemed to collapse into darkness, almost unnoticed. That is the mystery NASA's 2026 failed star autopsy is trying to examine in the clearest detail yet. A failed supernova is exactly what it sounds like. A massive star reaches the point where it should explode, forge shockwaves, flood space with light, and announce its death across millions of light years. Instead, the explosion stalls. The core falls inward. A black hole may form, and from far away, the star simply fades, like a lighthouse switched off in fog. That is the what. The how is stranger. When a very massive star runs out of fuel, its core can no longer push back against gravity. The center collapses in a fraction of a second. In a normal supernova, that collapse launches an outward blast strong enough to tear the star apart. In a failed one, gravity wins. The shock loses power. Most of the star falls back in. Picture a demolition charge that goes off inside a skyscraper. But instead of bursting outward, the whole building drops into its own basement. And the reason this matters right now is that astronomers are no longer talking about this as pure theory. They have candidates. They have years of data. They have infrared afterglow, disappearing visible light, and the kind of forensic evidence that turns an old suspicion into a crime scene. One of the most famous suspects is N6946-BH1, a red supergiant in galaxy NGC 6946, about 22 million light-years away. In 2009, it brightened in a weak optical outburst. Then it faded. By 2015, deep observations with the Hubble Space Telescope showed the visible star was gone. Spitzer saw lingering infrared emission, consistent with dust and fallback material. In 2023, follow-up work with JWST strengthened the black hole interpretation by finding a surviving infrared source that fits hot circumstellar dust and possible accretion, not a normal surviving star. That is the part I can't shake. We're used to death in the universe being loud. Supernovas look like declarations. This looks more like an erasure. A star perhaps 25 times the sun's mass, reaching the end of fusion, and then slipping behind a curtain of dust and gravity. Personally, that feels less dramatic and more disturbing. Fireworks are easier to accept than silence. Astronomer Scott Adams and colleagues drew attention to this object in a 2017 monthly notices study, proposing that the star had likely become a black hole through a failed supernova. The idea was bold because astronomy usually works with ruins, not disappearances. We see the wreckage after the fact. Here, the evidence was the absence itself. But there was a problem. A hidden, surviving star wrapped in dust could mimic part of the signal. So astronomers had to test competing explanations one by one. Was the star still there, just obscured? Was this an unusual weak supernova? Was it a giant eruption like the one seen in unstable luminous stars? That uncertainty is what makes the 2026 autopsy so important. It is not just another telescope update. it is an attempt to separate burial shroud from grave. And this is where the mystery becomes cosmic horror. If N6946BH1 really collapsed quietly, then some fraction of the universe's most massive stars are not decorating space with brilliant remnants. They are producing invisible graves. Black holes born with almost no announcement. Empty coordinates where a sun used to be. So let me ask you this before we go further. Dust-hidden survivor or real failed supernova? Which explanation sounds more convincing to you right now? The mechanics behind that choice are brutally physical. In ordinary core collapse, neutrinos carry away enormous energy, roughly 10 to the 53 ergs, and a tiny fraction helps revive the outward shock. If that revival fails, the envelope falls back. The newborn black hole keeps feeding. Matter spirals inward, heats up, and can create a faint, delayed glow, especially in infrared if dust is present. It is less like a bomb and more like a drain opening under an ocean liner. Everything slides toward the center. That fallback may also explain why some stars briefly brighten before disappearing. When the core loses mass through neutrinos, the outer layers can puff outward and unbind only weakly. Not enough for a classic supernova, just enough to shed gas. Think of a thermos in a blizzard. The heat inside is still there for a moment, but the cold wins, and what escapes is only a little vapor before the whole thing goes still. A 2013 study by Christopher Kochanik and collaborators argued that the loss of gravitational binding from neutrino emission could launch a weak transient, even without a full explosion. That prediction matters, because N6946BH1 did show a faint outburst before vanishing. Not a contradiction, a clue. Another clue is scale. NGC 6946 is nicknamed the Fireworks Galaxy because it has hosted about 10 observed supernovas in the last century, far more than the Milky Way over the same period. And yet, one of its most important stellar deaths may have been the one that barely flashed at all. There is something almost ironic about that. The loud galaxy may have given us its quietest crime scene. Can you imagine standing in a universe where suns can disappear the way a breath vanishes on cold glass? No blast waves sweeping across space, no glowing shell. Just one less star in the census. This changes more than our horror vocabulary. Changes black hole demographics. If many stars above roughly 18 to 25 solar masses tend to fail rather than explode, then some of the missing high-mass supernova progenitors stop being a puzzle. They did die. We just did not see the funeral. Astronomers have wrestled with that red supergiant problem for years. Fewer observed progenitors of Type II supernovas at the highest masses than models seem to expect. Failed explosions could be part of the answer, and that has consequences for everything downstream. Supernovas seed galaxies with heavy elements. They stir gas, trigger later star formation, and leave neutron stars or black holes with different mass ranges. Change the number of silent collapses, and you change the chemical bookkeeping of galaxies. Iron is bridges, blood, train tracks, frying pans. If fewer stars explode, fewer stars are flinging that material back out into space on schedule. But wait, there is a deeper reason the 2026 autopsy matters. It is not only about confirming one dead star. It may be our cleanest, real-time look at a process the universe usually hides behind glare. In a bright supernova, light overwhelms the scene. In a failed one, missing light becomes the signal. Astronomers can study dust, fallback accretion, and the aftermath almost like pathologists studying tissue after the noise has stopped. NASA's role in 2026 matters because this is the era when multi-observatory forensics becomes powerful enough to revisit old candidates with sharper infrared sensitivity and better modeling. Hubble gave the disappearance. Spitzer gave the dust. JWST sharpened the case. New archival reanalysis, infrared monitoring, and black hole formation models now let astronomers ask a harder question. Are we finally watching the transition from star to black hole, almost in place, frame by frame, without the usual supernova fireworks blinding us? Personally, I think that is one of the most unsettling ideas in astronomy. Not because it is violent, but because it is efficient. The universe does not always perform. Sometimes it deletes. There is also a practical scientific payoff. If astronomers can build a reliable checklist for failed supernovas, weak precursor outburst, optical disappearance, persistent infrared emission, no surviving luminous star, then future sky surveys like the Vera C, Rubin Observatory's legacy survey of space and time could find more of them. Instead of trading vanishings as oddities, we may begin counting them systematically. Invisible graves would become a population. And once that happens, black holes stop being only monsters found by collisions or X-ray feeding frenzies. Some become the residue of stars that died in near secrecy. That reframes black holes from exotic endings to ordinary missing entries in a galactic census. It is the difference between hearing a cannon in space and hearing nothing at all. Then realizing the recoil still moved the ship. Silence can be evidence. If that idea hit you the way it hit me, that a star can leave behind a black hole by almost refusing to glow, leave a like. Just for that twist alone, this case deserves attention. There is one final payoff here, and it is a human one. We often imagine the cosmos as spectacular, because spectacle is what our eyes reward. Rings, jets, explosions, aurora-colored nebulae. But reality is under no obligation to be cinematic for us. Some of the biggest transformations in existence may happen like a door closing in another room. N6946-BH1 is haunting because it suggests that absence can be the most honest signal in astronomy. A star lived for millions of years, fused heavier and heavier elements, swelled into a red supergiant, and then perhaps crossed the final threshold with barely a flash. The universe did not hold a public ceremony. It just kept going. And maybe that is why this story sticks. It forces us to accept that the cosmos is not only a theater of bright endings, it is also a field of quiet removals. Suns erased, gravity closing over them like deep water over a sinking anchor. So when NASA and other observatories keep dissecting this failed star case in 2026, they are doing more than checking whether one object survived. They are asking how many stars die without witness, how many black holes were born in silence, how many places in the night sky are not empty at all, but but occupied by something dark that used to be a sun. Confessionally, that possibility makes the universe feel colder to me, but it also makes it more real. Not every ending arrives with fireworks. Some arrive as subtraction. If silent cosmic endings fascinate you, subscribe. This channel is for people who want to see the universe the way it really behaves. Not just when it shines, but when it quietly takes a star.